Hello everyone, welcome back. So in this video we are going to understand the problem we have is longest balance substring 1. This is a different problem. It's a 3713 and the question is saying that the substring of S is called balance if all the distinct character in the substring appears the same number of times. Okay, means the character, this is not about the odd and even, guys, right? Make sure that you have gone through the previous previous questions where we have seen the odd number of and even number of should be equal. This is completely different. It is saying all the distinct characters, right, in the substring appears the same number of times. Then we have to return the longest balanced substring of S. Okay, so if you see, this time we do not have the number, but this time we have is a string. Okay, so it is saying the string having a characters, right, a set of characters, and if we will find a substring in that, so we have to check that all the characters of the substring should be same number of times. It should be there. Let's suppose very first we have given this substring. If you want to find the longest substring, so let's suppose we will take A, B, B, A, and we will not count C. It means this is the substring it is talking about. So the both distinct character is A and B, which is exactly coming 2 times, right? And so the given substring is, we can find the length, and we have to return the length of the longest substring, which is 4 of this size. So we will return like this. So this is what the question is saying that, and we have to implement in such a way, right? So if you pause this and if you go through the constant, right, you can understand it is saying that the length is the length of the string character is less than equal to 1000 maximum and consists of English letters. This is what it is saying, and it is very important to understand the pattern first. Okay, so the problem is that we should understand the pattern. Every questions have some patterns. So what is the pattern of this problem to solve, right? Very first, if you see here the input and the required things, we have to find the longest balanced substring, right? It means you have to fix the start, correct? You have to fix the start, and then you have to expand the end. If you understand the 2 pointers sliding window, right, like that we used to find I and J. So I, we can say, is a start and end is a J. So very first, if we'll fix the start and we will expand the end, then we have to maintain the frequency, right? So if we have to maintain the frequency, why will maintain that? We'll understand later. First thing, that the pattern, if you have already worked on, we have fix the start, expand the end, and then we will maintain the frequency. Once these things we will do, we only need to do what is validate mathematically or conditionally, we can say that mathematically. Okay, so this is the pattern we have for this type of questions. If we need to find the, let's suppose, the longest balanced substring, longest something, longest, right, whatever it is saying that, right? So the pattern is there. Basically, this type of pattern is where the enumeration start index should be there. Then we have to grow the window using the expanding the end, and there will be a frequency, right? It means the frequency condition should be checked, right? So if you say the basically the pattern will be where the enumerate start index will be there, then we will keep expanding the window through the end pointer, and then we'll check the condition through the frequency. It means, so here the patterns appears because we have, first thing is we have a substring problem, right? So whenever the substring problem is there, we should see the pattern. Okay, then we will check what is the constant we have given, and we have seen that the given string length is less than equal to 1000. So if the length is less than 1000, it means what? So it will take O of n square, which is allowed. Okay, make sure that you understand these things. Okay, very first, it is a substring problem. Another thing is the given string having the length could be 1000, so it is giving O of n square, which will allowed, right? Because when we are checking with the start and end, right, we are expanding the window, you may get O of n square, right? Third condition is that condition depends on the frequency of character, right? So with the condition check that we are doing, that completely depends on the frequency, right, of characters, right? But order doesn't matter. Order doesn't matter here. So these things we can do by what? Sliding window. But if we know that these are the conditions are there, right, but sliding window is tricky here. Okay, so this is what we should understand about how to implement this. The question saying that it is a balanced substring. It means what? Balanced substring means what? All the non-zero frequency are equal, right? Let's suppose if we are taking C, right, means what? It is non-zero frequency. It has some frequency should be there, right? So this is, we can say, the balanced substring means what? All non-zero frequency are equal, which is equivalent to what? Equivalent to, if there is some max frequency is there, we will multiply the distinct character, right, which is equal to the substring length. Okay, let's suppose what is the max frequency. So max frequency, if we'll find A and A is coming 2 times, B and B is coming 2 times, means max is 2, right? Now we'll say how many distinct character is there in the substring. So we have taken what? A, B, B, A. It means A and B is 2 distinct characters. So if you'll multiply by 2, it will give you the 4, which is our answer. Are you understanding? So that is why if you talk about the balanced substring, balanced substring means all non-zero frequency are equal, which is equal to the max frequency. I can say max frequency and the distinct character, right? How many count of a distinct character, we can say count of distinct characters. Okay guys, if both are equal, let me clean it so you will understand what I'm trying to say here is, so we are talking about the balanced substring. Balanced substring means what? All non-zero frequency are equal. It means the max frequency, if you multiply with distinct character count, right, which will be equal to what? Substring length, correct? So this part you should understand, because if we will take this substring that we have A, B, B, A, what is the maximum frequency here? The maximum frequency is 2, and because how? A is 2, B is 2, correct? And how many characters are there? Distinct character is A and B, so it is also 2. So the max frequency is 2 into 2, we are getting is 4, and this is what our answer is, right? So if you want to find the substring length, right, which is max frequency in the distinct character, we can get it. So the hidden problem is we have to check all the frequency equal, okay, and that we will do mathematically invariant thing, right? So that is a real trick is here to you understand that. So this is actually a frequency based substring pattern where you have to fix the left pointer and you have to move to the right pointer, right? So let's suppose you will fix left pointer here, right, left pointer, and you have to move the right pointer like this, right? And then you will maintain the frequency array. There will be some array where you will let's suppose A, you will say what is the frequency is there, then you will say B, what is the frequency is there, like that you have keep going, right? And the condition that we will check, that will come into O of one time, because only one pass we need to do over the given substring, over the string, right? So you will probably see a similar in the longest substring with k characters you have seen, right? If you know that longest substring with k. Remember the problem? So if longest substring with k distinct characters is there, so this type of problem you have seen that. You may also have seen a problem longest repeating character replacement, correct? You have seen also longest character repeating without repeating character, count number of string with equal frequency. So if you have seen those problem, right, it is exactly based on this type of problem, right? So let's talk about what is the general pattern here, the general template to solve this type of problem. So keep a note I'm giving for yourself to understand, right? Let's suppose we will create a for loop, right? So the left pointer will start from 0 and it should go to I should be less than n and I plus plus. So you will make the very first loop like this, then you should reset frequency, right, structure, make sure that you will do that. Then you will create another loop of left and j you will start from, let's suppose I, and j should be less than n and j plus plus, you will do that, right? Now you have to update frequency with s at j. Okay, now you will use the condition if the condition satisfied. Okay guys, if the condition satisfied, it means you have to update our answer, right? This is a simple template that you should understand, or not simple, you can say this is a general template to solve this type of problem that we have talked about. Okay, so keep a note of this. The very first I equal to 0 will go to the full characters, then we will reset the frequency structure, then we'll go for the j to expand the window, and we'll update the frequency with s at j, and if the condition satisfy, we will update our answer. This is what we will do. So when we will do these things, right, when we will apply this template, when the sliding window shrinkage is complicated and when the substring length is less than 1000, right, when the condition depends on the full frequency distinct, right, then we can apply this type of thing, right, this type of template. Now you will say, okay, this template will work, why the sliding window doesn't work here, right? Because the classical sliding window will work when the condition becomes invalid, right, and can be fixed by moving the left pointer. So here if the frequency mismatch, right, if the frequency mismatch by removing the left character does not guarantee the correction. Okay, so this is not a shrinking window problem but an expanding variation problem, right? You know the window shrinking problem, right? So this is not a window shrinking problem, guys. Either we are moving this side or we are moving this side, right? But this is a expanding problem, means we have to expand from side. Let's suppose either by this side or this side, or maybe both side, it depends on the condition. So when we talk about, it will guarantee you to O of n square, which is the best way to approach this type of problem, right? Sometime if the interview will ask what is the pattern that you are going to use, so if you say the brute force with the frequency optimization using some mathematical variations, condition apply, right, we can say that. Or in simple way we can say that we have to use inverting all the substring with incremental frequency tracking. That way you can explain them, right? So let's come back to the code and we'll try to understand here how to implement it. So we know that we have the given string is there, right? It means we also have given the condition is if and the length, I'm talking about the length of the s, right, string, if it is less than 1000, right? So what we can do, 1000, so what we can do is we have to fix a starting index, right guys, I, and we will expand j, correct? And then the very first thing we'll do, fix the start window, then we have to expand the window by j, we can say, and third we have to maintain three things. First is frequency, let's suppose 26 characters we have, so that we have to check. Then how many distinct characters is there, that we will check. And the frequency, max frequency, we can say the max frequency we will check. And in the fourth thing what we need to do is we'll check the condition. Check condition, what is the condition is there. We know that if we have the max frequency, right guys, you just need to multiply the distinct, right? If you multiply the distinct, this is nothing but which is equal to what is substring length. If it is true, then it is balance, correct? This is what we have to check. So let's go back through the code and you will understand. So very first, as we have discussed, we have to use the max length, right? And this max length we have to return as an answer, right? It means max length we have to update. How we will update that? So we'll check if the frequency, max frequency is equal to the length, right? You will update the max length, and you will get from the current length, you will update the max length, and you will return the max length. This is what we will do. Okay, coming back to on the top, what we need to do is the current length of the given string. We'll create a variable max length, and we'll keep track the max length, okay, of each substring. So from the given string, there will be multiple substring will be there, right? How we'll get that? We have to fix the starting index I, and you have to expand the j, right? And what we will maintain? We will maintain the frequency of 26 character, distinct element, and the max frequency. 3 things we will do, right? Then for the each character, let's call s at j, or s at caret, we can say that there will be some character will be there. We'll check its index. If its index contains equal to 0, it means it is a distinct character, right? So we'll update the distinct frequency count, right? How many times it is coming, that we will update. Then frequency index I plus plus will do, and we'll update our max frequency by just checking the max frequency of this character. What is the max frequency? Actually, max frequency we have to update it. For that we have to check the maximum frequency of any character from 1 to a to z, right? You will update the max frequency, right? And you need to find the length. How, if you find the max frequency, so how will you find the length? You know that j is moving ahead, means expanding, I is fixed, so you will j minus I, and to adapt you have to do +1, right? Because this is what we need to do when we are finding the length of substring in an array or substring, or string. Then you have to update the max frequency by max length of the max length of the substring, and then you will return the max length. This is what we have to do, guys. In case if you have any doubt, please ping me in the comment box, anything related to this, right? And I'll help you definitely there. You will say why this condition will work, sir. So very first thing is that if the distinct, let's suppose is d or distinct is every character appears k times, right? We can say that. So we'll say length will become what? D into k, which is equal to the max length. We can say that means the 2 into 2 is equal to 4, we can say that, right? So this guarantee all the frequency is equal. Okay, so this is what we have in this video, guys, and I have already told you what are the problem you can solve by using this template, right? And in case I'll put in the comment section, you can get the code from there, and I'll see you in the next one. If you're struggling with DSA preparation, you can join our online classes, and you can learn in the structure way of learning pattern wise, so you can understand DSA, and you can apply for the top companies. Thank you. Bye bye. See you tomorrow.